Okay, so our first speaker, Kaushal Sali, is a master's student at the Center for Music Technology, Georgia Tech, working on deep learning applied to audio in the music domain. This morning we will hear about a project involving the conversion of a hands-on exhibit into a web interface, for which Astrid was the first author of the paper. Take it away.
All right. Hello, everyone. My name is Kaushal, and I'll be presenting the paper From Museum to the Browser, Translating a Music-Driven Exhibit from Physical Space to a Web App. So what this paper is about is this interactive exhibit called GrooveMachine. And I worked on GrooveMachine as a software developer on the web app during the summer. So I'm really happy to be presenting this paper here at the Web Audio Conference on behalf of all my teammates, and I would like to thank Astrid for this. Okay, so let's get into it. So, what is GrooveMachine? GrooveMachine is a tangible museum exhibit that aims to foster interest in computer science through music-driven exploration of a computational system. So, this is an exhibit which is aimed for children from ages around 10 to 14. And the purpose of this system is to look at computer science not from the point of view of something that you have to do, but rather something that you would want to do. And to give you a brief introduction, GrooveMachine is a tabletop interface where you can place different blocks on the table, and depending on what blocks you've placed there, it makes music. So in this presentation, what I'm going to discuss is what GrooveMachine is, how it works, and how it achieves this goal of generating interest in computer science. So I'll be discussing the role of interest, the context, the museum and the browser context, the physical design of GrooveMachine. Then I'll discuss a short observational study which suggests that GrooveMachine is indeed able to trigger situational interest. And then how we basically translated GrooveMachine from the physical thing to the browser. So why does interest matter? So in today's world, computer programmers are the inventors, the creators of new technology. And this is the technology that is being used by every one of us. But however, not everyone is part of the technology creating population, and joining this population is not easy. Research has shown that there are high failure rates in computer science courses. There might be other obstacles such as poor teaching, lack of support from your family, or stereotypes associated with being a computer scientist. But however, intrinsic interest is a factor that can help you to persevere through these obstacles and pursue computer science. So when I say intrinsic interest, you might think that this sounds something like it's an inborn trait. However, that is not true. So Hiri and Renninger say that describe this four-phase model of interest development, and they broadly classify interest into situational and individual interest. So situational interest is something that is triggered by environmental stimuli. It is highly motivating, however, it does not last long. In order to completely develop interest, what you need to do is you need to maintain this triggered situational interest. And through this, you can basically generate individual interest. And GrooveMachine basically tries to achieve this goal. So we need to understand the context of where this setup, where GrooveMachine is going to be set up in order to understand how it was designed. So museums are places which are ideal for exploratory learning, and these are places where people are free to go and interact with exhibits as they want, as per their will, and there is no obligation for them to stay at these exhibits, which is why while designing an exhibit, you must keep in mind that an exhibit must be designed in such a way that it continuously engages the learners. Um, and that's why a considerable interest has been developed in active prolonged engagement, or APE. So one of the factors of which is prolonged engagement, and we conduct this observational study to measure this prolonged engagement factor. So considering this museum context, we designed the physical GrooveMachine table. And so this is the explanation of exactly how GrooveMachine works. So GrooveMachine is a step sequencer with 8 radial steps. And the reason why it was made a square is to promote collaboration. Because it is a square, it has 4 obvious places where you can stand. And it is the size is in such a way that kids cannot reach all the way to the other end. So this means that you have to work in teams and like you have to work as a team. Um, the table has arcade controls on four corners, and which are made for because of familiarity to kids, and because of their appeal. And these controls control the global parameters such as like volume, the tempo, the genre, and the direction in which the sequencer proceeds. You have these blocks that you place on the table. So as you can see, there is a central hub which has connections, and this central you can place all these all these tangibles, as we refer to them, on the table and attach them to the hub. There are two main types of tangibles. One is the sample, which is the blue one, and then there are four modifiers. So the sample has one sound associated to it, and the modifiers just add some attributes to this sound. Um, so there are four types of effects. One is the reverse effect, beat repeat effect, low orchestration, and high orchestration. The reason for these tangibles being you can see that these tangibles are made in such a way that they form these tessellating blocks. This is because tessellation has shown to be an effective method of engaging children in mathematical exploration. Also, they are symmetric so that you can look as to what the other person is doing and gain intuition from that. So the question is, how does this help in computing or computer science, right? So it's all about the metaphors for computing. So the step sequencer is a metaphor for the computational loop. Then you have the samples, which act as objects in object-oriented programming, and the modifiers are parameters which you provide to these objects. So we saw how GrooveMachine was made. So we conducted a whole time study to actually see whether GrooveMachine is indeed able to generate this interest. So in July 2018, in Chicago's Museum of Science and Industry, this study was conducted where the approximate ages and interaction times of groups were noted. Um, in seminal age studies, the average time spent was 3 minutes and 18 seconds. So we recorded 72 groups and saw that the average time spent was 4 minutes and 26 seconds. And we verified these results by conducting a one-tailed t-test, and these are the results. So the conclusion of this whole time study was that GrooveMachine was indeed able to trigger situational interest. But as we saw, situational interest it does not last long. So we need to deepen it or maintain it, which is precisely why we developed a browser version. So the browser version helps for deeper exploration of GrooveMachine and provides a pathway to exploring other CS learning platforms, such as EarSketch and TunePad. Okay, so now before we discuss how exactly the web browser implementation works, we need to find the differences between museum context and the browser context. So there are these three questions, main questions that we need to answer. So when people interact with the system, who are they with? So in the museum, usually you expect people to be in a group and interact as a group. But whereas while using a browser, you would usually using as a single user. So why are they here? So museums are places of learning, and when you come there, you have this mentality of curiosity, basically. But however, browsers are multi-purpose, and you can basically use them for anything. How do they experience it? So in museums, you have multimodal ways of experiencing experiencing it, where you have like visual, sonic, haptic, and aesthetic responses. And whereas in the browser, it is usually just audio visual. So to do this, we need to identify what are the core aspects of GrooveMachine that we need to preserve. So we formulated these into two types, like formal, which is the interaction and UI, and this is the main interaction and UI components that we want to preserve are the step sequencer and the tessellating blocks, and the functional aspects are exploration and discovery. So let's take a look at the browser version and discuss these differences in detail. All right. All right. So as you can see here, the square shape of the table, so I'll discuss the main differences. And in the museum, the square shape was quite crucial for the group interaction. However, this doesn't exactly translate to the browser because the interaction here is with a single user. And which is why we can get rid of the square shape and instead replace it with something more visually appealing like this, and which conforms more to this metaphor of the loop. The next thing that you can note is that, so in the physical version, you had these tangibles which were placed around the table. And we are free to pick these up, put them on the table, and see what kind of sounds they make. However, in this thing, in order to avoid visual clutter, we added them into these drop-down drawers. So the idea here is to maintain this exploration factor, right? Um, So people can drag them and place them on the table. And when the thing passes over it, it is not making a sound. Okay, that was weird. All right, yeah. So I'll demonstrate how these different kinds of effects work. So you have the low orchestration, high orchestration, beat repeat, and the reverse effects. So you can use these different objects and place them and try to figure out, like explore and discover new effects. So one thing you would note here that the samples here have these dots on them, and the tangibles in the physical implementation did have these dots. So the reason for that is it's pretty simple reason actually. So what happens when you drop these tangibles outside is that go back into the drawers, and sometimes if the drawers are not open, you might not know where the tangibles are going. So just to provide a sort of hint, but not to make it like super obvious, we added these identifiers on the samples, which make it clear that okay, where which sample this is referring to. Um, the So I will, okay, yeah. So then the global factors, the global variables that you had, the global variables that you had were in the form of these arcade controls on the Groove machine, which control the global variables. So what we did was is that we moved them to the down, where we can control different aspects such as the volume, the tempo, and the direction of the sequencer. Yeah, you can also control the different sample packs. Right. So you get the idea. With this, so there was an important discussion that we had about the number of modifiers that we provide. So you can see that there are 8 samples, but there are not 8 modifiers. The reason here is that if you so if you have 8 modifiers, you can basically create this whole complete shape, like a flower or something. But our goal here is not to achieve a end state or an end game, because this is not a game with like a end result. You want to maintain this aspect of exploration and discovery, which is why when you have four modifiers, you are forced to basically try out different combinations and see how that affects the overall sound. And then the main thing is coming back to this, coming back to the connection between computer science. So what we can do here is make it, in the physical implementation, what we had is we had printed out the connection, how GrooveMachine relates exactly to computer science. But in the browser, we can make it even more clear by adding the visualizations of how exactly the state of all the code is affected by doing different changes. So it shows that the modifier number 5 has been added to that operand. Yeah. Okay, back to the presentation. Right. So for the technical implementation, all the graphics were implemented using Pixie.js, and the sounds were implemented using Tone.js. And the sounds that for low orchestration, high orchestration, and sample are basically pre-recorded sounds, which are downloaded at the beginning of when the application starts, and the reverse and beat repeat effects are applied in real time. So the conclusion here is that GrooveMachine was a system designed to foster interest in computer science, and the preliminary indications that situational interest is triggered. However, to maintain this interest and develop it further, we developed a browser version so that people could deepen this interest. Yeah. So these are the references for the papers, and we acknowledge the support of NSF. And thank you. You can try out the app here at this link. Yeah.
Thank you very much. We'll take questions. There's one up there. I don't know if anyone's, you know. And then one there. Okay.
Hey, hello, thank you. I want to ask the question if we need another tangible sequencer, because of course we need it, like we need all these live coding languages. It makes the world richer, right? But so this looks like something you would use as a complementary thing to the museum visit, right? Like kids would come to the museum and spend 3 minutes 18 at the installation and then go home and continue playing around with this. Has this been published? Do you have some data on that? Is that the idea? Has it been done? What about that?
I'm sorry.
I mean, will this be connected to the experience in the museum, or it's a project?
Yes, so that is the whole idea.
Yes,
so,
right.
Yes.
And do you have some data? Does it work? Do people adopt this? They go to the museum and then they go home.
So
and
the browser version hasn't
yeah.
been tested yet. Like if so, the browser version is actually still being developed, and it is like almost ready. But there no whole time study kind of a data has been yet conducted on the browser version. Does that answer your question?
Yeah, kind of. I guess the idea is that you go to the museum and then you go home and you continue playing on the browser.
Right.
But it hasn't been published yet, so you don't know if it works. I'm very interested in this after the museum situation, but it doesn't.
Right, so it hasn't been, okay. A study hasn't been conducted on that.
Pity. Yeah. Good luck, and I hope you come back and give us some data if that worked.
Great, thank you. There was a question here. Maybe I can get to it quicker.
Is there any relationship to the project Groove Pizza from NYU Music Experience Design Lab? It's called Groove Pizza and it has a
I am actually
similar.
not aware of it.
Ah, okay. Well, I thought it was like some kind of spin-off or okay. There is this project from the Music Experience Design Lab from the NYU, and it's the loop idea is similar.
Okay.
Yeah, it activates some parts with the.
I see. I'm sorry, I'm not aware of it. Okay.
The question in the Slack is, what was the link to GrooveMachine? Can you post it there in the Slack? Maybe you do it afterwards.
Okay, right.
We'll put it back up on the screen in a second.
I will do that.
It's not localhost 8080, I guess.
No, right. So the one I was actually, I showed you was like an older version till the point I worked on it. So this is the updated version or like the latest thing that is there right now. So it might visually look a bit different.
All right, thank you very much. I think we have to move on,
Okay.
but let's thank our speaker once more.